Okay, I want to try to simplify as much as possible how to graph a sinusoid. I want you to understand what you're doing, at least to some extent. And I think the best way to do that is to deviate slightly from the way your book arranges the equation of the function. So here's the way the book arranges things on the left and names all the things. And it seems very complicated to me. So here is a way I will be showing you on the right. So please stick with that way. It is slightly different. It's not terribly different, but it's different enough that if you try to use the left-hand way, you may get confused, and you'll confuse me if you ask me about it. So a major difference between the form the book uses and ours is that we are going to factor the x coefficient out in the argument of the function. And this helps us to see the period of the function and the phase shift more simply, I think. So when we get the function into this form, here is what we are able to see. So we're getting it into this form, y equals a plus b sine c times x minus d. So just to make sure you're with me, we're not using this way, we're using this way. All right, so when you get it into this form, here's what a is. When you add a to a function, you're going to have a vertical translation up or down. If a is positive, you slide the function up. If a is negative, you slide it down. So when we look at our function, when we get it into this shape, this form, we know that the line y equals a is going to be the horizontal center line of our function. B, when you multiply a function by b, you get a vertical shrink or stretch. So if the absolute value of b is greater than 1, you have a vertical stretch. If it's less than 1, you get a smush. Bottom line, the absolute value of b is the amplitude of the function. If b is negative, this also is going to reflect the graph across the x-axis. So we have to keep an eye on that. C, the period of the function is going to be 2 pi over c. And you can also say that as c is going to be 2 pi over the period. So that's what c tells us. D, when you add or subtract something from x in a function, that is when you translate it horizontally. So if you add a positive number to x, that's going to slide the graph to the left. If you subtract a positive number from x, the graph scoots to the right. So D is what is called our phase shift. So one idea that helps me graph a sinusoid is to consider that every time the function passes through all the angles in the unit circle, it completes one period. And I can break that period up into 4 parts, the 4 quadrants. 0 to pi over 2. So as we go from 0 to pi over 2, sine increases from 0 up to 1. That's the first quadrant. So my graph goes from 0 to 1, and that piece looks like that. From pi over 2 to pi, the second quadrant, it decreases from 1 back down to 0. As we go from pi to 3 pi over 2, the third quadrant, the function decreases even further down to -1. And then as we go from 3 pi over 2 to 2 pi, it increases back to where it started. And that's one full cycle. So because I can split up the period into these 4 pieces, the 4 quadrants, whenever I'm graphing a sine function, I always split the period into 4 parts. I divide it by 4 and see what I get. And that's how I know how to divide up my x-axis or my horizontal axis to graph it. And I'll show you what I mean by that when we do an example. We have y equals 3 sine x. Whatever you multiply that by is going to be your amplitude. So this will look just like a sine x function, which just looks like this, where you're going up to 1, down to -1, and so on. When you multiply the function by 3, all that's happening is you're multiplying all those y coordinates by 3, and the function is stretched so that now the amplitude, that is the distance from the maximum down to the center line, or the minimum up to the center line, that amplitude is now 3 when you multiply cosine by -1/2, you are doing two things here. You're smushing the amplitude down to 1/2, and you're taking the reflection across the x-axis. So the function will be upside down from what it normally is. So the normal cosine function looks like this. So it'll start at its maximum. As it approaches pi over 2, it goes to 0. Then as you go from pi over 2 to pi, it goes to -1. And then as you go from pi to 3 pi over 2, you come back to 0. And then as you go from 3 pi over 2 to 2 pi, you're back up to the maximum again. That's what the cosine function does. So since we're multiplying it by the negative, we're not going to start at the maximum. We're going to start at the minimum. So this flips everything upside down, right? So we're going to start at -1/2, and instead of decreasing, we're going to increase. We'll go up to 0, then we'll go up to the maximum, which will be +1/2, then we'll go down to 0 again, and then back all the way down to -1/2. So this is what that function is going to look like. Okay, now we have a graph of 4 sine 3x. So now we're multiplying sine by 4. That number tells us the amplitude. We're going up to 4 and down to -4 this time. The period, remember I said, is 2 pi over whatever that coefficient on x is. So the period is 2 pi over 3. That means that this function will complete one full cycle in 2 pi over 3 radians. In order to mark my x-axis appropriately, I will divide that number by 4 so that I can divide the period into 4 equal parts where I know it will go through the first quadrant, second quadrant, third quadrant, fourth quadrant. So when I divide 2 pi over 3 by 4, I get pi over 6. So I'm going to divide my x-axis up into pieces of pi over 6. So I know that now, as I go from 0 to pi over 6, that's going to cover all the values in the first quadrant. So that's going to take me from 0 up to 4. As I go from pi over 6 to pi over 3, I've got to do the second quadrant. I've got to do all those values. So I'm going to be going from the maximum back down to 0. As I go from pi over 3 to pi over 2, I've got to get the next part of this thing done, which is to get all the way down to the minimum. And then as I go from pi over 2 to 2 pi over 3, I've got to get the rest of it done and get up there back to 0 again. So I got all the whole period done in 2 pi over 3 radians. And so if you keep going now, all the way to 2 pi, you can see that the function completes 3 cycles in 2 pi radians. So that number 3 also tells you that. Okay, so I want to get this into the form that I explained at the beginning, because now I can quickly see 5 is the center line. It's the line that goes horizontally right through the middle of the whole thing. 2 is my amplitude. 4 is the number that is 2 pi over the period. And 3 pi over 4 is my phase shift. So once I get it into this form, I can see all those things. So first of all, 5 is the center line. That means that this function doesn't have the x-axis going through the middle of it. It has the line y equals 5 going through the middle of it. Then you can see that 2 is the amplitude, and that just means that now you're going to go up from 5, up 2 spaces to 7, and down 2 spaces from 5 down to 3. Then I can see, like I said before, that 4, that is, I factored out, the period is equal to 2 pi over that number. So 2 pi over 4 is the period, which is just pi over 2. So I'm also going to break that period up into 4 pieces. So pi over 2 divided by 4 is pi over 8. And that tells me that I want to break up my x-axis into pieces of pi over 8. So my period is pi over 2. It's that much space. And my phase shift is 3 pi over 2 to the right. I'm subtracting it. So that means I'm scooting the function over that many spaces to the right. So the function is now over here It's like your new origin is right there. So that's where this whole business is going to begin. All right, remember that a cosine function starts at its maximum and decreases. There it is. That's it. So that's one full period in just pi over 2 radians. So that is what that function is going to look like. And if you look at the basic sine function that goes down and then back up again like that normally, if I just scoot it over a little bit and show you, this function completes 4 of those V shapes, those one cycle for a cosine function in the time that it would take just a regular y equals cosine x function to do this whole thing one time. And that's, again, what that 4 right here, that coefficient in the argument of cosine tells you is how many times the function will complete a cycle in 2 pi radians.